Hey, to you, welcome back. Um, Problem number 283. Let me just confirm. Move zeros. So, in this problem that you're given, let me just 1 minute just to make sure that everything hold long. Okay, so you are given an array of integers called nums. Your task is to move all the zeros in the array to the end while maintaining the relative order of the non-zero elements. Also, you must do this in place, meaning you cannot use extra array to store your values. The key points of this one first, the in place. So the transformation must be performed within the original ID or the original array. Number two, a relative order, like the non-zero elements must appear in the same order they did originally. Also, we need to minimize operations. The solution should try to minimize the number of operations performance. So if you can see an example, this example here, if we have this nums, we should expect basically to move all zeros, and that's it. It's pretty easy. So in this example, the order of non-zero elements 1 3 11 or 1 3 12 remains unchanged, but all zeros are moved to the end of the array. We can create a solution for that. So if we think about a detailed solution, we can use a two-pointer approach. One pointer will I basically will traverse the array, and the other pointer, we call it j, for example, will keep track of the position where the next non-zero element should be placed. Okay, so if we want to think about step by step how we will do this, number one, we could think about first initialize our pointer, which will be j and j. So basically, this one will set j to 0, which marks the position where where basically the next non-zero element should be in place. And next we have we need to traverse the array. So here we loop through each element in nums using an index, which is I. And for each element, if the element is non-zero, we copy it to the next index, which is j. And then we increment j by 1. If the element is 0, we do nothing, simply move to the next element. By doing this, you effectively collect all non-zero elements at the beginning of the array while preserving their relative order. And I guess the third one is to basically to fill the remaining positions with zeros, because so after the first loop, index j indicates the position where the first zero should placed. We run another loop from index j to the end of the array, setting each element to 0. By the end of these steps, all non-zero elements will be in the correct order at the beginning of the array, and all zeros will be removed to the end. Okay, let's see how we'll do that. So as we said, first we initialize j as a pointer. So let's do this. Let j equal 0. And that's this is the first step. This is the fastest step. The next thing that we will traverse the full array. So give me a minute. Okay. So we will do this in two processes. The first one, we move non-zero elements forward, keeping their original order. So how we'll do that? We make a for loop. Let I equals 0. I is smaller than nums dot length. I is plus plus. Okay. I'll make if statement here if nums of I doesn't equal 0. Yeah, we just do nothing. Okay, yeah. we just do nothing. Yeah. Oh. Okay. So here, if nums of I equals 0, it doesn't equal 0. What should we do? I forgot. Yeah. Nums of j should equals nums of I. No. Should equals nums of I, and we move j forward after placing a non-zero element. So j plus plus. So yeah, that's it. It's a pretty simple one. And the next here we will fill the remaining positions with zeros. So after move all non-zero elements to the beginning and keep their order, we create another for loop. So in this for loop, let I should equals j, and since j is the index of the next I position element, so basically we start from there, and I guess it will be the same here. I less than nums and I plus plus. Here it will be pretty easy. Nums of I equals 0. And basically here we need to return I. No, return nums, sorry. Let's run. Let's submit. Okay, it did work. So let's make an example walking through. Give me a minute here. So let's say that, let me delete all of this here. Yeah. So let's say that we have this nums, this our nums. So if this our nums, basically we right now initially the first iterations I will equal 0, okay, which is nums of 0. So we have this one here. Yeah, so we have here this iteration. So 0 uncounted. So basically we do nothing, and j will not be plus plus. J will equals 0. Okay. J. I guess this is a bad j. So the second iterations I will equals 1. So I right now, let me delete this. Yeah. So I equals 1 here, which is this index. So I equals 1 and nums of I equals 1, which is non-zero. So we found non-zero encountered. So we will do as we see before. We increment j by 1. So j right now here we equals 1. And we place n of j before increasing j by 1. We put n of j with n of 0 equals 1. So our nums will look something like that. We'll start with 1 and 1 and 0 and 3 and wait a minute, my face looking this. So basically our array will remain the same, but we will have just here it will be 1. So 1 1 0 3 12. So we continue looping again, and right now I will equals 2, and then the index the element of index 2 is 0, so it's 0. So we do nothing, and we'll continue loop basically, and j stay 1 as it is. And the fourth iterations basically I will equals 3. Let me just delete that. So I here will equals 3, which will be the nums of the index 3 is actually equals 3. Yeah, it's good coincidence. So this one is not 0. So we found non-zero encountered. So we place this element, the value of this element, to the index of j. So it will be 1, 3, 0, 3, 12. And when we start in the next iteration, so iteration number 5, the iteration number 5, we have I will equals 4. Let me delete this. I will equals 4. And I equals 4, it's 12. So this is a non-zero. So we have non-zero encountered. So we place it with j. Of course, we did increase j for each one. So right now, I guess j is 3. Sorry. So since j is no, j is 2. J sorry. J is 2. J is 2. I forgot to increase j when I was updating the 3. So j is 2. So basically we'll put the 12 here, and we increase j by 1, so j will equals 3. So our array will look 1, 3, 12, 3, 12. This is the first pass. The second pass, it's pretty simple. We start from j and we make everything else 0. So this will be 0 and this will be 0. So 1, 3, 12, 0, 0, and that's it. It's a pretty easy problem. So yeah.